This is an emergency meeting of all departmental heads of the XYZ Furniture Company. That's Mr. Armstrong, the president. He called the meeting to discuss the loss of a $75,000 order. This has been one of several large orders lost in the last few months. According to Mr. Johnson, sales manager, it was production's fault. But according to the production manager, Mr. Smith, his department was not at fault. Let's take time out and analyze why this order was lost. February 1st, the $75,000 order for Futura chairs was signed at the customer's store for delivery before March 15th, in time for their annual spring sale. February 4th, the order was mailed to the plant. February 6th, it was received at the plant. February 8th, the order went through a credit check, where there was a 2-day delay because of the amount of small orders being checked. February 13th, the order was typed in the sales department. A couple of new girls were being trained on the job, thus causing another delay. February 14th, the order was checked for accuracy by another girl. A mistake was found and it had to go back. More lost time. February 15th, the order was received at production control. February 18th, a clerk checked the inventory status of Futura chairs. He found there was not enough in stock to fill the order. February 19th, the order was passed on to the production scheduling group to determine how soon the necessary chairs could be built. By February 20th, the production schedule had been analyzed. It was found necessary to revise all production plans in order to meet the March 15th delivery date. February 21st, based on this new plan, the supply of raw materials was checked. Not enough in stock to even begin filling the order. More raw materials had to be obtained. February 22nd, the order for raw materials was typed, verified, and signed. This was done more rapidly than usual because now they realized they were in trouble. From February 22nd to March 4th, they waited for the raw materials. Meanwhile, preparations were made so production could begin as soon as the materials arrived. March 5th, the raw materials arrived and production began. March 19th, production completed. March 21st, the furniture was finally ready for shipment, but it was 6 days too late for the customer's spring sale. Order canceled. So the furniture went to the warehouse instead. The bottleneck was paperwork. Actual production took only 16 days, but it took 28 days of paperwork and delay before production could even start. However, the problem did not end there. According to the chief accountant, The profit and loss statement for February showed that they had built up their warehouse inventory of colonial-style furniture to $150,000. This style was not selling as well as predicted, so they had to cut the price to $120,000 to get rid of it. This meant a loss of $30,000. To make matters worse, still more colonial was in production. By this time, everyone was well aware of the problem. But what was the solution? How could management control be improved? Hire 100 more clerks? No. There's a more practical solution. Industry has a powerful new tool for handling paperwork operations and for improving management control: electronic data processing.
Electronic data processing, genie of business. Almost like a story out of the Arabian Nights, electronic data processing has suddenly appeared as a new helper for the businessman. A machine with many of the characteristics of the human mind, it follows management's instructions exactly. This is not tomorrow's dream. It is equipment ready and available for use today. There are electronic machines available in many price ranges, including large equipment, medium-size equipment, and even small equipment that can be applied to numerous computation problems in business. What are the major characteristics of this new management tool? First, and perhaps most significant, is the computer's ability to carry out a long series of operations without human intervention. To accomplish this, the machine has stored inside it all of the different procedural steps that it must follow. When there are several alternative procedures that might be used in a given case, the machine automatically selects the right procedure and follows it. All of these procedures can involve many thousand individual instruction steps. The second major characteristic is that of memory. The machine has two basic types of memory, one being a large volume type of memory for storing the files of the business. The other is a small volume, high-speed memory where all of the procedural steps are retained. To illustrate the large volume memory, a life insurance company might have several 100,000 active insurance policies. All of the information on all of these policies can be retained on tapes such as these, and the machine could search automatically for a desired policy record. The third major characteristic of these machines is speed combined with accuracy. Instructions and data stored on this rotating magnetic drum can be selected by the machine in a few thousandths of a second, or can be selected from these magnetic cores in a few millionths of a second. Reports for management can be printed out at fantastic speeds also. This printer can print up to 10 lines per second. From the teletype or from typist, information on punched paper can be fed directly into the computer. In watching an electronic data processing system in operation, you are struck by how few people are involved. This impression is misleading. There are more people behind the scenes than first meets the eye. In fact, the real challenge for electronic data processing is getting properly trained people. There is an urgent need for systems engineers who lay out the broad procedures under which the system will work. Then there is the need for skilled programmers and coders who write the detailed procedures for the machine. A new type of machine operator is needed who understands the operation of the machine and can get the work out on time. Tape librarian and tape changers who make sure that the file tapes are properly identified, and accurate data recorders who enter the information into the system. Eventually, we will see the work of the automation engineer, where the computer will directly instruct the machine tools in the production shop as to what parts to make and how many to make. The machines are here. Automation of the office can be a reality. Electronic data processing is truly a genie which can improve the competitive position of a firm, and it is here now.
To understand how these systems can benefit management, let's see how they operate. First, input. As a sales order is typed, the same information is punched on a paper tape and then transferred to magnetic tapes. One full typewritten order is stored on about 1 inch of tape. The magnetic tape then becomes the file of the sales orders, arranged alphabetically by customer name. All information ordinarily contained in several filing cabinets can now be stored on one reel of tape for faster reference. Next, processing. The electronic system includes a computer which performs functions such as checking, posting, analyzing, scheduling, summarizing, statistics, inventories, and so on. These processes reduce the mass of input data to the key information necessary for effective management. This one system operates faster and more efficiently than innumerable clerks. A high-speed printer translates this information in machine language into written human language, such as credit reports, shop orders, inventory reports, accounting reports, and so on. But computers will do more than clerical work. They can present to management essential data for more efficient control. For example, suppose the electronic system predicts not enough in stock for anticipated orders. Management is notified and can take action. Suppose actual sales are greater than predicted sales. The high-speed electronic system would detect such a trend immediately and would automatically compute a revised sales forecast. This allows management to adjust production to avoid bottlenecks. All this takes place at a speed impossible for any number of clerks. And now back to the XYZ company. How would this speed, accuracy, and greater control have saved their $75,000 order? First, sales orders would be typed and the paper tape punched at the numerous XYZ sales offices throughout the country. The tape would be airmailed or fed into a teletype line. The customer file tape unit would spin to locate the customer's record, and the processing machine would check his credit rating. If found satisfactory, the processing machine would go to the second tape unit, the furniture inventory file. The system would check the inventory level of Futura chairs. If there were enough, it would automatically order shipment from the warehouse. However, if the inventory were too low, as happened with Futura, it could notify management immediately. Management could then take action and use the electronic system to schedule the necessary production. Raw material supply would be checked automatically. If there were not enough raw materials in stock to build the required chairs, the machine would print out a purchase order. With the issuing of this order, the paperwork would be completed. This speed and efficiency would have saved 20 days for the XYZ company. The production deadline could have been met, and the $75,000 order would have been saved. But the advantages of electronic systems go far beyond this for XYZ, in fact, for everybody. For example, the consumer will pay lower prices. The customer will be assured of earlier deliveries. The salesman will have better customer relations. The employees will be engaged in more supervisory work and a less monotonous routine. The controller will always have up-to-the-minute financial reports. The department heads will have fewer crises, and the stockholders will have less of their investment tied up in inventory. Management will benefit most directly. The electronic system will provide all necessary data in time for effective forecast and control.